Hello, today's lesson's 6.3 linear functions. We're continuing on into unit 5, our functions unit. It is from chapter 6, unit 3, which is linear functions. After this section, we'll be having a quiz on 6.1 through 6.3. So let's get started. Today's daily objective is I can understand that the equation y is equal to mx plus b defines a linear function. I can write linear functions using graphs or tables. I can compare linear functions. So the key word here today is going to be our y is equal to mx plus b linear function. So you're going to get a question like, is this line linear? And if you can see that it's in that format, y is equal to mx plus b with slope and an intercept, it is considered linear. This is another one of those MCA questions. Is this linear? Then they'll give you an equation. So a linear function is a function whose graph is a non-vertical line. A linear function can be written in the form y equals mx plus b, where m is the slope and b is the y-intercept. Let's get going with example 1. Example 1 is from page 258 in your book. It says, use the graph to write a linear function that relates y to x. Okay, so if we have two components with these questions, if we have our rate of change, our slope, our m, and if we have our intercept, we can go ahead and write the linear function of this relationship. Okay, so if you take a look at this, let's first see if we can find our slope using our points on the line. Now, I'm not going to draw a line through these points, but I am going to start with this point right here. And I'm going to go from this point down here over to this point here by rising 1, 2, 3 units and running 2 units. So I'm going to go up 3, over 2. So our slope in this case is going to be 3 over 2. Okay, and it's going to be a positive. So you can see this line goes uphill from left to right. Now you could look at the change in the y, in this case -6 minus -3, which would be -3, over the change in x, which would be -2, and that would be the same, 3 over 2. So in the book, you're going to notice that they actually do take 2 points and use those 2 points to find the slope. So I'm going to now focus in on this point right here, 0, -3, because at 0, -3, that would be considered the intercept. So right where I circled right here at y equals -3 would be where it crosses the y-axis. So in this case, b is equal to -3. So the line crosses the y-axis at -3, at 0, -3, so the y-intercept is -3. So we're going to write ourselves this linear function. We have our 2 pieces of our puzzle, our m, our slope, and our intercept. So our answer in this case would be y is equal to +3/2 times x plus a -3. And you just wrote that function using those points on the graph. So keep a lookout for those types of problems today. Basically, you're taking points on the line and you're writing the linear function. You're writing the linear function using the 2 components of slope and intercept. Okay, let's move on to example 2. In this case, we are given a table. And we're going to be asked to use the table to write a linear function x, which relates y to x. okay? Now, if you had to graph these out, it would look something like this, okay? And I'm just gonna kind of have a general shape of the graph. -3, +9, -2, +7, -1, +5, 0, +3. Now I hesitated there because if you think about this, that is going to be our intercept. So right away we know where it crosses the y-axis at 3. So our b is equal to 3. Okay? So you can see it's got a negative slope line just by looking at the line. It goes downhill from left to right. So now all we need to do is determine what the slope is. So as y is changing, negative, it goes down to 7 to 5, it goes down to 5 to 3, it goes down to, and as y goes down 2, x goes up 1, again up 1, again up 1. So your slope is going to be -2 over 1. It's always going to be the difference in the y over the difference in the x, -2 over 1. That makes sense with how that line goes downhill. And your slope in this case would be -2. So your equation of this using a table would be y is equal to -2 x plus 3. So in essence, we found this equation mx plus b, where b is the y-intercept, 0, 3, where the point where it's at 0, 3, and the slope is -2 over 1, and that would be your answer. Y equals -2x plus 3 for example 2. Now on page 258, we have our first two on your owns. And with these two on your owns, on the next page, we're asked to use the graph or the table to determine our equation of our line. Okay, so let's start with number 1 first. Now keep in mind here, we're going to focus on y is equal to mx plus b. Okay, we're going to focus on finding the slope, finding the y-intercept, and then creating our equation. All right, so first off, slope. As you can see, this line has negative slope. It's downhill from left to right. It goes down 1 unit and over 1, 2. So it goes down 1 and it runs for 2. So in essence, your slope in this case will be a -1 over 2. Rise is negative down, running of 2, -1/2. So you can fill that in next to the x. Now let's take a look out for the intercept. And where it crosses the y-axis is at -1, this point. 0, -1, and it's the y-coordinate. So in this case, your answer will be y equals -1/2 x plus that -1. And there would be your answer for number 1. Number 2, -2, 2, -1, 2, 0, 2, 1, 2. Okay, so you can see here we have 0 increase, the difference in the y over the difference in the x. So you can see here you're going to have a slope of 0. But your intercept is right here at 0, 2. So your answer is going to be y is equal to 0x plus 2, or in other words, y equals 2. Okay, and that'd be your answer for 2, y equals 2. Now, keep in mind, if you had x all the same, we are going to have a line x equal to that value. Okay, so that would be number 2. If you didn't see that we had no increase, you could also just take your 2 points In this case, you're going up 1. So the difference in the y is 0 over 1. 0 over 1, your slope is 0. And you can see where your intercept is right there at y equals 2. So there's your answer for on your own, number 2. Now we move right into example 3, real life application, dealing with 6.3. Example 3, you are controlling an unmanned area vehicle, a UAV, for surveillance. The table shows the height y in thousands of feet of the UAV x minutes after you start its descent from cruising altitude. Okay, so it's going down, heights in thousands. It's going down. As you can see, it says at X minutes, 0, it's at 65 feet. At 10 minutes, it's at 60 feet, 60,000 feet. After 20 minutes, it's at 55,000 feet. After 30 minutes, it's at 50,000 feet. Okay, the question is, write a linear function that relates y to x. Okay, so let's take a look at y is equal to mx plus b. Okay, now when x is 0, it's at 65. So you can see right away, 65 will be our intercept. So if you think of a graph of this, 0, 65 is up here, okay? And that's where it crosses the y-axis at 0, 65. So you could put that b down as your 65. Now, your intercept is your 65, but now your slope is not as obvious, but you can take a look at the change in y, negative 5,000 feet. It goes down negative 5,000 feet. And it goes down negative 5,000 feet. So it goes down negative 5 as the minutes go up 10. Up 10. Up 10. So again, slope is the difference in the y, which is negative 5, okay, divided by the difference in the x, which is 10, okay, which is negative 1/2. 0.5, negative 1/2. So your slope in this letter A would be 0.5 times x plus 65. And that would be your linear function equation. Now, if you were asked to graph this, you would simply go ahead and start plotting your points. 0, 65, 10, 60, 20, 55, 30, 50, and so forth. Okay, and that's how a graph would look for letter C. Letter B, I should say. Now it asks you, find the height of the UAV when you stop the descent after 1 hour. Okay, so 1 hour is not in minutes, so you got to convert your hour into 60 minutes. Okay, so what they want you to determine is what is going to be the descent after x, when x is equal to 60. Okay, so let's take our equation. Y equals 0.5x plus 65. And now we're going to substitute in 60 in for x. So y is equal to 0.5 times 60 plus, now I forgot the negative here. I want to make sure I get, because it's negative, it's going down, plus 65. So in this case, your answer would be y equals negative 30 plus 65, or in other words, 35. So you'll be at 35,000 feet after 1 hour of descent. 35,000 feet after 1 hour or 60 minutes descent. Okay, that brings us to on your own number 3. What if? What if you double the rate of descent? Okay, let's go up here. If we're doubling the rate of descent, let's repeat A through C, letter A. Okay, so what that means is we are going to double our rate. So instead of going down by -5, we're going to go down by -10. Okay, so the same amount of time, we're going to double the rate of this descent. So we're going to go down, -1 is our slope. Okay, so for letter A, you would have y equals -1x plus, now our intercept is going to continue to be the same, 65. So our letter A would be -1x plus 65, and that's because our rate, which is our slope, went from -0.5 and it doubled to -1. Letter B, if you were asked to graph that, you would have a graph that would look like this. You would still have the same y-intercept, 0, 65, but your descent would be steeper, okay? Your steeper line, so after 10 minutes, it would be down to -10 plus 55, be down to 55, and so forth. Letter C. Letter C asks, find the height of the UAV when you stop the descent after 1 hour. So we're going to communicate 60 minutes again. So y is equal to -1 times 60 now, 60 minutes plus 65. So after 1 hour, the UAV will be at -60 plus 65. Doubling the descent will put you at 5,000 feet. 5,000 feet for letter C. Okay, now we're going to go to our last example, which is comparing linear functions. And I'm going to spend a little bit of time with this because this section, when we start to compare graphs, is it helps us when we're graphing and interpreting the information that's in front of us. Okay, let's look at this example. The earnings Y in dollars of a nighttime employee working X hours are represented by the linear function y equals 7.5x plus 30. The table shows the earnings of a daytime employee. So this is the daytime employee. Okay. The nighttime employee is y is equal to 7.5x plus 30. That's at night. It says, which employee has a higher hourly wage? Now, remember we talked about slope being rate, and wage is one of the things that can be considered a rate. You're getting paid per hour. Now, in this case, the hourly rate is the slope. So the hourly rate for the nighttime employee would be $7.50. Okay, so the nighttime has a $7.50. It's the slope, 7.5. That's the rate of change. Now the daytime employee has a rate of change of $12.50 per 1 hour. So as you can see, the slope is $12.50. So who has the higher hourly rate? This is pretty obviously, it's the daytime employee. It's the daytime employee. So again, you can see that by looking at the slope. The nighttime, this looks like an H, but it's an N. The nighttime employee has a $7.50 slope, $7.50 rate, and the daytime employee goes up $12.50 per hour as $12.50. So the daytime employee makes more per hour. Letter B, write a linear function that relates the daytime employee's earnings to the number of hours worked. Okay, so that's fairly simple. So as you can see here, the daytime employee has a y is equal to slope 1250 times x. Okay, 1250 times x. And as you can see that there, the 1250 is the slope, but there's not an added feature to the employee's wage. So the earnings y is equal to the hourly wage 1250 times the hours worked, which would be x. Okay, in the second part of this question, it says graph the linear functions. Okay, so if you were to graph this, the graphs would look like this. The daytime employee starts out at 0 and it heads up in this direction. The nighttime employee starts up the y-intercept and heads out into this direction. Okay, they intersect right here at a value of 675, 6 hours. Both of them are paid $75. Okay, it says let's interpret the graphs. Okay, so again, this is nighttime and this is daytime. Okay, now what this means is after 6 hours, they make the same amount of money. After 6 hours. But the daytime employee after 6 hours starts making quite a bit more money than the nighttime employee. Okay, now I'm not sure why, probably because at night they're not as busy. Okay, and they have a kicker at the beginning for a nighttime employee because that employee has an incentive to work all night. Okay, so I would say that that's the reason why. B, in the book it says your friend has a higher hourly wage but does not earn more money until you work more than the 4 hours. Okay, excuse me, that was the wrong one. The graph shows the daytime employee has a higher hourly wage but does not earn more money than the nighttime hour until the 6 hours. We already talked about that. And that'd be letter B of example 4. Okay, on your own next. Last one today for this lesson. It talks about a manager A earning $15 per hour and receiving a $50 bonus. The graph shows the earnings of manager B. Okay, here's manager B. Which manager has a higher hourly rate? Okay, so let's take a look. We're already told that A has $15 an hour. 15. Okay. Let's take a look at B. The rate in this case will be up 25 over 1. So it appears that the manager B has a rate of $25 an hour. So every hour he's working, he's getting another 25. So it's the rise 25 over the run 1. Okay, so let's see, it goes up 25 on the y-axis. Okay, so in this case, the manager's, the slope, the rate of the manager's pay is $25 per hour. The manager A has $15 an hour. So manager B has a higher hourly rate. Okay. All right. Then it says, after how many hours does manager B earn more money than manager A? So what we have to do is we need to put down manager A's graph onto the same graph and see where they cross. Okay. So we're going to start at the $50 bonus, because when manager A comes to work, he gets a bonus right off the bat at $50. Okay. So 50 after 1 hour, he's at 65. Okay, so I'm going to put that right about here. 2 hours would be another $15, would be at 80, be right about there. Okay. 3 hours would be 3 times 15 would be 45, be 95, so it's be right about there. 4 hours would be 110, which is right about there. 110. Still, you can still see that he's above the line. After 5 hours, that'd be 5 times 15 would be $75 plus 50 would be 125. So as you can see, the manager A's pay scale extrapolated out in a graph, after 5 hours, manager B will be making more money. Okay, so after 5 hours, you can see that manager B is making more money. It's this part of the graph. Manager A is the top line. But as you can see, the graph drops below manager B after 5 hours. So they want to know why. It says your friend has a higher hourly wage. Okay, your friend, excuse me, I made that mistake again here. It just says after 5 hours. It doesn't say to explain it. That's another extra example we have to do sometime. Okay, so this concludes the lesson. It basically, this section, as we went through, you're comparing linear functions. You're writing linear functions using graphs. So use your slope, use your intercept. If it's in the form of a line, it should be in y is equal to mx plus b. And we did some comparing of linear functions. So hopefully you found this section beneficial, and I hope to talk with you soon. Thank you very much for listening.